My name is Cannon Purdy. I work at Scripps Institution of Oceanography, and welcome to the Scripps Technical Forum. The Scripps Technical Forum is a group of students and researchers here at Scripps and our industry partners coming together to share technological advances and applied technology. This forum is an opportunity to connect with case studies and applications of the different technologies, both used by our industry partners and here at Scripps, and we're really excited to have you join us. Just a few housekeeping announcements. Please use the Q&A in the webinar format to share any questions or comments you have, and we will have a portion at the end for Q&A. We also received some of your questions online at registration, so we'll be sure to get to those. If you have a comment, you can also raise your hand, and if anyone's calling in, I believe it's *9 to use that. And we have recordings of our previous Scripps technical forums online, stf.ucsd.edu. Please connect with us. Douglas Alden and Vanessa Scott are our fearless leaders of the technical forum, and stay tuned for more events as the fall quarter continues. And that is it for me. So I will turn it over to SubC Imaging, our guest for today. We have Brent Lackey. Brent, a mechanical engineer with a mechatronics specializations from the University of New Brunswick, boasts over a decade of invaluable experience as the lead engineer at SubC Imaging. In this pivotal role, he has been at the forefront of pioneer camera system, LED, and laser designs for SubC Imaging's revolutionary underwater imaging solutions. Brent's unique blend of engineering acumen and dedication to technological innovation has been instrumental in shaping the future of subsea technology, setting industry standards, and keeping SubC Imaging at the forefront of innovation. So welcome, Brent. And we also have Matt Mulrennan. Matt is the founder and CEO of Colossal. Matt is a fellow of the Explorers Club, and Matt, a marine scientist, technology enthusiast, and conservationist. For over 12 years, he has worked in ocean exploration and conservation as a staff researcher at Scripps Institution of Oceanography, woohoo, a marine scientist at Ocean Conservation Group Oceana, director of the Ocean Institute at the X Prize Foundation, and he was the CEO of Invest. Alongside Colossal, he works with ocean and climate investing funds. At the helm of Colossal, they have become one of 20 candidates for the 2018 Pritzker Emerging Environmental Genius Prize. Colossal was the grand prize winner for the Connex Tech Prize for prototyping a deep sea camera system. He has a master's in marine biodiversity and conservation from Scripps and a bachelor's in environmental studies from Miami University. So welcome, Matthew and Brent. Thank you so much for being here today. And I will stop sharing and pass it over to you.
Okay. Matt, over to you.
Yeah, all right. Hello, everyone, and thank you so much for your time today. We're going to give you a great presentation about our expeditions to Antarctica. We're going to talk about the Colossal Squid. Stick around to the end. We're going to show you some really cool footage from the season. Brent's going to give you a really great overview of the tech that we deployed. So again, I'm Matt. I was a researcher on this expedition. We did 4 expeditions to Antarctica last season, and would love to chat with you guys about what's coming up next as well. So if you have suggestions and ideas, and even maybe some students that want to go to Antarctica, we may have some options for that as well. So Brent, you want to say anything as well about yourself that we didn't hear?
No, nice to meet you. That was a robust introduction. Yeah, I'm the lead engineer from SubC Imaging. I've been with SubC for a little over a decade now, and this is just an absolutely fantastic journey throughout this project.
Right, yeah, and Brent and I were on the first expedition to Antarctica this year. So let's jump into it. Big squid, So I've been obsessed with this creature since 2007. Colossal squid is the largest invertebrate in the world, maybe up to 10 to 12 meters long. Biggest eye in the animal kingdom, about as big as a soccer ball or about as big as your head. It has bioluminescent headlights. We might be using this to find food or camouflage. One really interesting concept about it, it has swivel hooks on its tentacles as well as hooks on its arms, and it's in its own genus. Only living in the Southern Ocean, and we started learning a lot more about it when it started biting toothfish, Chilean sea bass, you might know that as, on fishing long lines in the Southern Ocean. So really unexplored area in the deep sea in the Southern Ocean, as you know. And really when we started fishing there in earnest in the 1990s is when we started pulling them up to the surface and actually dissecting them and studying them more. So let's go to the next slide. Okay, so a few of these pictures, only a few whole specimens have ever been caught, 8. It's never been viewed in its natural environment. And most of what we know about it is actually just from capturing a few individuals. So the first one that you're seeing in the gray was caught in a net in 1980 by Dr. Alexander Meslow, our former advisor, who unfortunately did pass away from COVID-19. And he became one of the world's experts on the colossal squid. The first one that was ever found was in 1925 in the stomach of a sperm whale. And then there's a huge gap in understanding after that. So it was first described way back when. And then, as I mentioned, it started biting these toothfish. So you see a gouging bite mark out of the toothfish there, as well as sucker marks all over the animal. So that depredation was very obvious. Then they started bringing them up. So in 2007, you're seeing that the net next to the large squid there, they caught the largest one ever in the world. And it is now in Te Papa Museum in New Zealand. So they dissected it in the last image. In New Zealand, they were about to build the largest microwave in the world to defreeze it. And then they learned a lot more about the squid from that. So we've been working with some of the researchers who did those dissections and actually studied the colossal squid. So these are more about the adults, and then we don't know a lot about the juveniles. And we're going to talk to you a little bit about, did we find one of the juveniles in the shallower waters? So we did film a glass squid down there, and we've actually been going back and forth with the researchers about, is this the first time we've witnessed it in its natural environment? All right, let's go to the next slide. Okay, so these are 2 images I just took recently. I was in New Zealand. Auckland University of Technology has a bunch of the babies, the small colossal squids, and then gets quite large. So I took myself a picture of it next to the big squid, which is in Te Papa Museum, the Museum of New Zealand in Wellington. So you can learn a lot more about it there. Actually, there's quite a few experts in New Zealand. And we actually are going to partner with Auckland University of Technology for this season. They're going to be deploying some eDNA scanners down there, and we're going to try and find more of the juveniles in some of the shallower waters on the same vessel that we used last year, a tourism vessel. And we've been going down multiple times each season with provided berths by Intrepid Travel. All right, let's go to the next one. So yeah, the main goal, and I set this out in 2015, was to find and film the colossal squid in its natural environment before 2025. So that's coming up pretty fast, actually. This would be the 100th anniversary of the first discovery of the species in 1925 in the stomach of the sperm whale. So we still don't know a lot about the largest invertebrate on our planet, and that's pretty incredible to me. So this season, we'll talk a little bit about our findings later on, but we did surveys throughout the entire Antarctic Peninsula, up to South Georgia Island, Falkland Islands, all within the Southern Ocean on this tourism vessel that goes to Antarctica. So we use the deep sea camera system that we're going to talk in depth about today. We use some red lights as well as some squid lures and some flashy lights, and deployed those as well. So we try to use the best information that we have about the colossal squid's locations, and we use that toothfish information really to discern that. We also are finding a lot of new discoveries out of this. So we'll talk about the 4 publications that are coming out of this last season. And the big major goal is conservation in all of this. So we'll discuss that a little bit more detail as well. But really trying to draw people in with the squid and with the science, and trying to make some conservation outcomes out of all of this for Antarctica. All right, the next one. So this is kind of what we know about the colossal squid's distribution. There's actually quite a few of them. They're not that rare. And it could be a substantial amount of the biomass in some animals' diets. So they think that there's quite a few, but this is based on some of the information from the individual whole specimens, and they catch a lot of arms and tentacles as well as the juveniles in some of these surveys. But they also find it in a bunch of different species, albatross and the toothfish and penguins. So it is a substantial part of the diet, as well as in a significant way, sperm whales. And in some cases, 90% of their diet was potentially colossal squids. And they find the beaks in their stomachs that are preserved there. So that's most of what we know about it. Again, refined information, not great on the animal, but mainly in the deeper waters, could be 2,000 meters or deeper. For the adults, we do think that they sink as they get larger, and that the juveniles are staying in shallower, more productive waters. All right, let's go to the next one. So this was a really cool partnership, as mentioned. We have SubC Imaging, and thank you so much to Brent and to Chad for their work on this, that developed the camera system and provided it for the whole project. Colossal, my team that I run, they did a great job. We've been working on this for 7 years to lead up to this point. Marine Institute out of Canada provided researchers and some next-gen grad students into this project that came down with us. And then Intrepid Travel provided the vessel. So the Ocean Endeavor, huge thanks to the crew and the expedition team, and to Will and Brittany for all the work that they did in helping make this whole season go forward. So it was a really cool partnership where we've been able to do science in a really remote region, a very low cost, very low carbon way, and really getting some big value add. And we also talk to the guests and get them engaged, and it's just been all around a really great project for engagement, as well as some really cool science out of it. So yeah, thank you to all the partners that helped out with the season, and it is going to continue on. We are right now planning out next season, which is going to happen in 2024. All right, let's go to the next one. All right, sweet. Hand it over to Brett, the expert on the tech.
All right, thank you very much, Matt. Appreciate that. Hello, everyone. It's great to be here, share this amazing journey with all of you. My name is Brent Lackey, lead engineer here at SubC Imaging. My role in this project was basically to head the design, development, fabrication, assembly, and testing of the technology used on this project, and to work with the different partners to get things integrated on the vessel itself. I was also lucky enough to be on the inaugural expedition alongside Matt during our first deployments. So let's start with the technical challenges. When this idea was first proposed to me, it honestly sounded a little bit crazy. I was told, and I quote, "Let's drop a camera down from a cruise ship in Antarctica to find the elusive colossal squid." Not normally a statement someone would come to my desk and talk to me about. So that's quite a statement. First, we needed equipment that will work at the South Pole. How do we deploy from a cruise ship? What tech do we use? And how do we bring it all together into a working system that's repeatable, easy to use, and would require minimal training to operate? We were going to get researchers from Marine Institute, and we needed something that they could just go down and use, and it wouldn't be overly complex. So if we summarize the requirements for this, it basically consisted of needing a system that could be dropped from the ship, a cruise ship, with real-time video monitoring and control, measures in place to ensure the system didn't touch the sea bottom, 4K recording, digital stills, and lights. So, choosing the right equipment. The first step was to figure out what kind of camera we'd be using. One option is a standard Ethernet camera, but that would require lots of conductors in our cable, and unless it's interfacing directly with an ROV, it's not quite the best for long distance transmission, so that one was out. The next option was something like a fiber camera, which can do long distance video transmission, but would require quite an expensive cable, and a cable that's liable to get banged around quite a bit when we're in Antarctica. So that one's not ideal either. Another option is a coaxial unit to transmit video. And while a lot cheaper than fiber, it still requires a more complicated cable for video and control transmission. So that one is not ideal either. Our final option, and what we decided to go with, is SubC's BPC camera. So that's boosted power line communication. and that's what we decided to go with. So this camera utilizes a form of Ethernet mixed with power over a single set of twisted wires. This allows for real-time video monitoring and full control, simultaneous 4K internal recording and digital stills. It enables us to actively watch the video feed, ensure we don't touch the bottom, react to the environment the system's in, and allows for a very simple data cable with only 2 wires to power everything and provide Ethernet connectivity. And this is what we decided to go with. The camera also has a integrated depth and temperature sensor, giving data logging for each deployment, and an internal IMU, inertial measurement unit, to give us orientation of the camera and heading information. So for lighting, for our main sources of lighting, well, at depth, we basically have no ambient lighting from the sun. And we decided to go with 2 of our underwater Aquaria MK3 LEDs and opted to go with 1 white and 1 far red. The white LED, while illuminating an underwater target, gives us a more natural looking image with proper coloration. It does, however, tend to influence whatever is being illuminated. It can act as a beacon for some fish while scaring others away. It might be in the video later, but like krill would really be attracted to the white lights. The red LED, on the other hand, is a wavelength that is readily absorbed by water, so it doesn't penetrate deep into the water column, and therefore most sea life never evolved to perceive it, or they can't perceive it very well, and this allows us to still illuminate the area, but not influence the sea life. With our camera, we're able to independently control the 2 connected lights. So we can toggle between red and white as needed, red to illuminate the area and kind of see what's going on in a more natural situation, and white to turn on to snap pictures and get good colored photos. We also have some other colors like green and blue, but we didn't think they would be quite applicable here. And to give you an idea how bright the LEDs are, think of like a typical street light. Double that, and that's about equivalent to one of our LEDs. We did also have a multicolored light lure that Matt procured, and that was we were able to set that to multiple different colors. And Matt can speak a little bit more on that, on how it could potentially attract the colossal squid. So no seafloor contact. That was a key requirement for this project. And to achieve that, we decided to use an impact subsea altitude echo sounder. It's a device that basically sends out a pulse-like sonar to gauge its distance from a target, and in this case, the seafloor. We were able to interface that directly with our camera, giving us real-time altitude readings directly in the camera software. So it's up in the corner of your field of view. The user can constantly monitor it. Another key thing to know when looking at underwater creatures and features is basically how big is it? To do that, we used our SubC Manta Ray dual parallel lasers. This is a set of 2 dot lasers, spaced 10 centimeters apart, and they're calibrated to be parallel to one another. By being parallel when they land on a fish or a starfish on the bottom, a rock, or even the colossal squid, it doesn't matter how far away the object is because the gap between the lasers is always the same. So when you use we can use the dots as a reference and figure out how big the object is. This is a simple yet really effective method for determining size when underwater. We also specifically use green lasers as the wavelength isn't absorbed very well by water, and it gives us the furthest range, as opposed to something like a red laser, which is absorbed much more readily. So we need a red laser several times more powerful to achieve the same range and intensity. So since our BPC, our boosted power line communication camera, only requires 2 conductors, we're able to use a really small relatively small 9mm Kevlar reinforced cable with a single set of twisted conductors. So it gives us a working strength of 500 kilograms, about 1,100 pounds, and a breaking strength greater than 1,500 kilograms, or about 3,300 pounds. The addition of Kevlar makes the cable incredibly strong in tension, making our cable double as the lifting cable. So it simplifies things a lot, as we only have the 1 cable to deal with. We don't have to worry about a metal wire strength member with a data cable routed alongside it. It's just a single cable, and that's everything we need. So for cable management, we decided to use an electric winch as opposed to something like a hydraulic winch. It was just the easiest solution on a vessel that has electric power, and it made the most sense in this application. So we've worked with a company called AGO Environmental, who have taken our specific requirements for our towed camera system, which I'll elaborate on in a second. And through a lot of back and forth over the past several years, we created a winch that met our exact requirements. And the requirements for our towed camera system are basically the same as our drop camera system, which is what we developed for this project. So safety is a priority whenever using a system like this. And one main concern when towing or dropping a system down in the water, especially near the seafloor, or in the case in Antarctica, with relatively minimal seafloor mapping and only a general idea of the seafloor topography, is snagging the system. So our winch has an integrated slip clutch, which means when the load is beyond a specific threshold, with that threshold being set a bit above the normal operating conditions you would expect, but below the safety rating for our cable, then the cable will start paying out. So instead of worst case scenario, your frame was to snag on a rock, instead of immediately going taut and putting a lot of stress on the cable, potentially snapping it, putting additional stress on your winch, it'll start paying the cable out. It gives you an opportunity to stop the vessel, assess the situation, and then you can attempt to free the unit by putting higher loading on the cable if needed, but it gives you an opportunity to stop and deal with the situation safely. So the system, we decided that instead of starting a drop system completely from scratch, that we actually had a great platform to base things off of. We took our TCS, our towed camera system, which is designed to be towed behind a vessel and will passively maintain a consistent seafloor altitude. This allows for seafloor transects, and we use that as a base. So you can see that down in the bottom left of the image on your screen. We have impact resistant epoxy coated aluminum panels and spars, coated syntactic foam, a pivoting mechanism to rotate the LEDs and the camera together. Each LED can also be angled in and out to hit a target at whatever operating distance you're going to be at. The entire camera and LED assembly can tilt from a forward-facing orientation in increments down to looking straight down. Everything can be disassembled and replaced if anything becomes damaged. And since this is the tow system, in that diagram, the tow bridle is on the front. Now, using this system as a base, we created what's on the right-hand side of the screen with Matt there. That is our DCS, our drop camera system. So using the TCS as a base, we created a modified version that actually is still compatible as a tow system, but now has a vertical bridle harness for dropping the system down. The syntactic foam was removed since we don't need the buoyancy in this application. We also added directional fins, that's the blue panels you can see in that image, to catch the current and keep the frame from spinning. If the system didn't have this, it would catch the current unevenly and potentially start spinning in the water column. This would end up twisting the cable, causing damage, and obviously a spinning video feed isn't ideal. So unlike our TCS, our towed camera system, where its buoyancy was important to how it works in maintaining seafloor altitude, our DCS, our drop camera system, needs to be heavier, and locations for weight were added to either side of the frame. And you can see that on the right-hand side of the frame there in the photo. The reason for it to be weighted is that when you drop something down in the water with any kind of moving current, it's always going to sway to the side. And instead of your cable going straight down, you'll get a slight tilt of a few degrees. And it's not bad if you don't have much current, but as that current increases, this angle gets greater and greater. So this not only means your system ends up not being directly below you, but somewhere off to the side. It also adds up to a lot of potential depth when your cable is only so long. So by adding weight, that tilt gets less and less. And of course, there's a balance to be made between making the system heavy enough to deal with those high currents, but not so heavy that it's cumbersome and you're unable to deploy it easily. We also added mounting for an altimeter to be mounted directly to the frame, and left room for other sensors like a USB-L to be added if required. That's essentially like a underwater GPS and would give us the exact position of it underwater, but we didn't have one of those available for this mission. So, system fabrication and testing. Everything was designed, developed, and fabricated here in Newfoundland, Canada. Previously, we had tested our towed camera system at the Marine Institute's flume tank, which is also located here in Newfoundland. And it's the largest flume tank in the world. It holds about 1.7 million liters of water, about 450,000 gallons. It's absolutely enormous. So what is the flume tank first? Basically, it acts as continuously flowing water. So instead of needing to drag something behind a boat or rig something up in a harbor and wait for the current to pick up to see how it operates, we can basically just use a dial and turn the water speed up and watch what happens in a controlled environment. Water is circulated from a main tank with pumps through a flow straightening device and back into the main tank. This results in consistent water flow down the length of the tank with variable speed, up to about 1 meter per second or about 2 knots. Which is about what we were expecting to encounter during our deployments. So due to the size of the tank, we're luckily able to do full 100% scale testing with the actual equipment we're going to use. And we decided to test the drop system here, and the goal was to determine how the cable angle would change versus water velocity, and determine how much weight we would need to add to the system to keep the cable angle down to a reasonable value. We also wanted to test how the directional fins worked and if they kept the frame pointing into the current and stopped it from spinning. We eventually decided to put about 80 pounds worth of additional weight on the system. And after some experimentation with different fins and how they attached, we got them working great. They kept the system always pointing directly into the oncoming current and stopped the system from spinning. So you can see here in the right-hand image, this is our prototype version. So we just have some weight hanging off the bottom and some plastic fins off the back and a bait arm coming off the front. And that was our initial prototype, and we got it working great. So vessel setup. The first question we had to answer was, where in the world do we deploy the system from? This isn't a small vessel. It's certainly not a scientific research vessel with a nice deployment area. So multiple ideas were tossed around, but we had some pretty strict requirements. We had to be away from the propellers for obvious reasons, had to be away from the thrusters, away from the anchors, and eventually someone suggested we look at the ship's pilot door. And this is the door the harbor pilot would use to when you enter port. And this is where we decided to use it from. We had to work with some pretty strict requirements with setting up our equipment, as the door couldn't be blocked and still must function as a pilot door. So everything needed to be out of the way after each deployment. And once the last trip was done, everything needed to be completely removable. We also needed some way to lift and push the system out the door far enough that it would clear the vessel and be lowered into the water. It also needed to fit within a very small footprint and needed to be completely removable and collapsible once the expedition was over. To make that work, the ship's engineers added bracing to the underside of the deck to deal with all the forces involved. The winch was welded to footings on the deck so it could be removed. And an extendable pivoting boom iron crane was installed on the deck. This gave us a solid location to pay in and out the cable, a collapsible boom arm that could lift the equipment up and down, rotate in and out the door, and whatnot. You can see that here on the right-hand image. This is the boom arm crane we used, and it gave us a lot of versatility in maneuvering the system outside the vessel and deploying it into the water. And finally, our system deployment. So this is really where everything finally came together. It was a long road to get everything developed and tested, and to do so based only on what we thought would be required down in Antarctica. We didn't have as much information as we would have liked at the beginning. So a lot of it was guesses. Keep in mind that we were never able to actually even do a single mock deployment before arriving in Antarctica. The equipment had to be prepared in advance of the expedition, everything put on board in Newfoundland, Canada, and the ship left the same day it came in, not really leaving any time for trials or experimentation. So it wasn't until we were on board the vessel and in Antarctica that the entire system could actually be fully set up. Things installed, everything tested. It took some trial and error and provided lots of challenges to overcome, but in the end, we succeeded. A brief overview of how deployment worked is we would drop the system into the water. We're able to constantly monitor the video feed, its depth, its altitude from the seafloor, its orientation to know if everything was hanging correctly, and had full control over the camera, controls, and lighting. We would switch between red and white lights as needed, adjust our image settings based on environmental factors, and of course, always be recording. When close to the seafloor, we would be monitoring the altimeter, constantly jogging the winch up and down to maintain consistent altitude and ensure we were safely above any entanglements. And by having real-time control during deployments, it let us be active users. So changing our depth, adjusting settings for conditions as needed, reacting to what we see, and allowing us to carefully examine the seafloor. This would have been quite a different experience if we had to blindly send a camera down, wondering if we were getting the footage, not knowing what's happening until we get it topside again. So I'm going to send this over to Matt now to talk about some of the challenges that we encountered.
Right. Yeah. Thanks so much, Brent. So bottom line, this whole thing worked. And as Brent mentioned, it was very customized for this project. And we put it through some rigor down there. We put it through ice. We obviously have the waves and the currents bashing this thing around on, when it's being deployed or in between when you're underway. It's pretty calm down in Antarctica, but we definitely hit some Drake passages that were quite significant. The depths and the drips, as Brent mentioned, really had to keep it down deep. And the currents down there are really strong, some of the strongest in the world. So, and you can see that in some of our imaging, is that stuff drifts by really, really fast. So we had to keep it stable and in one place. We also wanted to keep the cost down, and we had to make sure we can pick this thing up and take it with us. So the permitting process was also part of this entire thing, that we couldn't sit on the seafloor, and we also wanted to make sure that everything comes with us in one piece in between. We also had to, have people video editing in 5-meter plus waves. We kept people up all night. We got a couple of our researchers on the call. They still like me, but we did some all-night deployments during some long trips. And so it was all the fun challenges you could imagine about Antarctic research. And we were still able to deploy and retrieve this thing safely every single time, download the data, and get it to people and do some cool science with it. So operating in Antarctica, if you haven't, was a challenge. Icebergs, definitely, that was the most significant one. We had a lot of situations where we had to pull up quickly or avoid things or not deploy in certain regions. And that is an ever-changing, ever-present issue in Antarctica. So so that was probably our major one, but also a fun one as well. Kept us on our toes. All right, so our season recap. You can go to the next one. So like I mentioned earlier, we did 4 expeditions. I was at sea for 58 days this year. We took down 7 different people, majority female next-gen researchers as well, which was fantastic. We did 36 survey locations. We were at 20 meters deep to down to 400 meters deep throughout the Antarctic Peninsula. Went to the Shetland Islands, went over to the Weddell Sea, which is largely opened up, a lot of melt there from the ice. And there's significant areas that are being explored for the first time recently. Marguerite Bay, all the way below the Antarctic Circle. So that was super cool and interesting. It's an area that most tourists don't usually go. So that was significant. We have some cool findings from down there as well. Then we went all the way up to South Georgia and the Falkland Islands. And we do think that the colossal squids are off of South Georgia significantly. They have been spotted there, and it's a prime spot for toothfish fishery as well. So we got 62 hours of 4K film, a lot of stuff on the sea floor all the way up to the midwater holds as well. All right, next slide. So we got a couple of these people on the call, and thank you to Myra and Jenny for putting up with my terrible jokes for way too long. They were on the ship with me for 21 days when we did the South Georgia cruise. This is us off of Elephant Island, where Shackleton was marooned. His men were marooned, and we followed in the footsteps of Shackleton over to South Georgia, which was really interesting as well. So we got 80 different species identified at least. Still going through it. We got 4 papers under prep from the season. It's an interesting permitting process. We went through the US State Department and the EPA. You have several layers of permitting to do this for a tourism vessel, but it is pretty simple process if you already have existing permits from the tourism group. So that was really great. As I mentioned, really great, unique partnership to do this, to keep the costs low and to get people on the ship was really fantastic. Huge thanks to all of them. We had to develop all of this and deploy it, as mentioned, Brett mentioned, pretty quickly to get on the ship in Canada, out of Newfoundland, and actually steam all the way down to Antarctica for the season. So it was a pretty rapid fire thing to get all of this set up, and then we had to deploy it successfully and repeatedly in a safe way. So all of that worked great, and we didn't have any issues. So they developed a really robust system that I tried repeatedly to break in all sorts of terrible conditions, and we failed to break it. So to do this, we did some media on it. We got some national press, especially in Canada. We're on the CBC. We did a crowdfunder with this, and we raised some money and some matching funds. I've raised some money from some deep thinkers as well. Some corporates, including Kraken Spiced Rum, was a supporter. And then we've done a bunch of outreach with this as well, which I'll speak to you a little bit about if we go to the next slide. So this is a slide that a lot of people seem to remember because I've never worked on a project where people were so interested in the outcome and so inspired by it. So we get all these letters from around the world with youths. The youths are really into this. And one of them, one of my favorite people is Jackson Wallace. He's 6 years old. He's obsessed with the colossal squid. He had a colossal squid themed birthday party, which you're seeing there. And they were a backer of our crowdfunding campaign. So we went back and forth and became pen pals. And he had, of course, some great ideas of how to find the colossal squid, basically exactly how we were doing it. So never underestimate a 6-year-old. People wrote the book of the colossal squid and how to find it. They were writing letters to Jenny at Marine Institute. So we had some really great fun with this, and I think there's a lot of excitement and attention to this that we want to captivate people with what's out there left to discover, and that's the essence of science, right? Just curiosity, and that's what these kids are all about. So we had one of our researchers, Eugenie. She posted this to TikTok, got 8 million views on TikTok, talking about searching for the colossal squid. So there's definitely some latent interest out there in the world, and we're trying to tap into that to keep this project going and really expand it and try to find an adult colossal squid soon. And it was next gen researchers. It was really everybody, I think, was under 40 on the ship doing this. So it was a really cool opportunity for everybody involved, especially some of the students, I think, at Marine Institute had an enjoyable experience. All right, next slide. All right, this is my first image that I took when I got to Antarctica. And it is a very special place. The bottom line, undergoing extreme conditions right now, obviously huge heat waves, and there's a lot of conservation that needs to happen there. They are trying to protect the Antarctic Peninsula. It is the most likely of the marine protected areas to go through, and that's kind of why we're doing all of this. We want to apply this into conservation outcomes. So you guys can get engaged in a lot of this as scientists, conservationists, but the bottom line is, please pay attention to Antarctica. I know Scripps, I'm preaching the choir here, because they're absolute experts in this region, but it's a very beautiful, unique, but fragile place. A lot of endemic species that only occur there, and they are very much under threat. All right, next slide. Now we're going to show you some clips from the season. So it's going to be a little bit choppy because of the delay on the Zoom, and we can't unfortunately fix that. So these are the Antarctic Death Stars, sunflower sea stars. We had volcano sponges. That one's wearing a crinoid hat. Here's a crinoid floating in the water column. Beautiful. We saw a lot of crinoids down there. We see ice fish. Got the antifreeze blood. Tons and tons of hydroids and soft corals, gorgonians. At one site, we saw hundreds and hundreds of thousands of scallops. It just went on forever, and the density was incredible. So some places the seafloor was completely abundant. Lots of jellies and other invertebrates in the midwater. We did a lot of midwater holds as well. And this one, we're not sure the species. Obviously, an octopus, giant Antarctic octopus is possible. And they have found 4 species down there so far of octopus. And we saw a bunch during our deployments. Another one comes in here to the top right. He has a false eye. You see that black mark? And then he gives us a little ink at the end. So again, some of them are venomous as well. Beautiful reefs down there, filled with life. You can see a dozen species on one rock. You can't see that at all on land in Antarctica. Another Death Star, beautiful creatures. We'll show you another clip. So this was off of Deception Island. You have a ton of tunicates, and I think we will come up on our dead fish. It was covered in brittle stars and sea stars. Anything down there dead is going to get consumed pretty quick. Again, crinoid alley, and then we'll see a dragonfish, I believe, pop on the top of the frame here. Really beautiful fish, incredible stripes and colors to it. We saw several dragonfish throughout the whole process. This is us baited up, trying to track the colossal squid. The adults, we use squid and toothfish, as well as a bait bag at different depths, as well as the red light and some flashy lights as well. This one's a siphonophore. And we saw a bunch of these, as well as a lot of the other squishies in the midwater, and some of the predators lurking about. So this one was pretty cool. Continue to light up as well. And we see a lot of ctenophores, which we didn't show here, but a lot of beautiful ctenophores coming out. So if you can pause it real quick, Brent, this is the glass squid that we found. This could be the first look at the colossal squid as a baby. It is not the 10 to 12 meter long one, but this could be the first time witnessing it in its natural environment. You guys are some of the first people on the planet to see this video. We've shown it to other glass squid experts, and we're going back and forth with them about what this is. It's either Galacteuthis glacialis, an adult, which is seen sometimes down there. It could be the colossal squid baby, or it could be a species of Theonius. So we're talking to the world's best glass squid experts, and it's still a little unclear. We're measuring certain things about their eyes and how they come out from the body, or the fin shape as well as the tentacles to arm length. So I went to Auckland University of Technology and saw some of the babies there as well. And we're still not sure actually about this finding yet, but we can keep it going. We might have lost our place. Sorry, Brent, I pulled this on you last minute. All right, there it is. That's the maybe baby colossal. And the red eyes are coming from the red light. We don't think those are photophores. Salp colonies, huge ones, some of them several meters long, and could take up the entire screen as we floated by. So I think we'll see another one here. We don't know where this one ended. So it could be 5 to 6 meters long. And yeah, huge salp colonies that came together down there. Krill, obviously, the base of the food web, and they loved our lights. They stuck with us for hours at times and would actually ruin the feed. At times we couldn't tell where the seafloor was because it was messing with the altimeter. We didn't know where it said it was the seafloor, and it wasn't. So it was giving us a false reading because there were too many krill in our way. But they were super fun. They dance in front of the camera. It's great. Sea spiders, the largest in the world, are down in Antarctica. You're seeing one here. Sometimes they'll ball up and go as a tumbleweed to move around faster. You have another Death Star. This one's hunting. It's got its rays up, and it's looking for food in the midwater. And then you have a crinoid here that's going to spring to life. And I just think they're just aliens. You know, they're just super, super cool. We saw huge sea pens, incredible sponge colonies, and we're going to show you a couple here of the giant volcano sponge. These are the oldest animals on the planet, can potentially grow up to 15,000 years old. Paul Dayton from Scripps actually did some studies on it back in the day about their growth rates. So just think about how much water that filters over hundreds to thousands of years, and how many animals are provided habitat. This was a really cool one. Myra was operating the winch when we got this one on film. This one was almost 1.5 meters high to 2 meters high, crinoids on the top, and then you can see a fish in the bottom of it. So huge giant volcano sponges down there. Really cool to see them. Definitely worthy of protection. I think any place that they're seen should be a vulnerable marine environment. So really, really awesome to see them. So this one, again, we had to get the camera out of the way because it was so large and it came out of nowhere, covered in crinoids, providing that 3D habitat. This is another dragonfish off of South Georgia Island. We saw a lot bigger fish there. And then in South Georgia, we started seeing a bunch of man-made parts off of a whaling station. I told Chad originally, we'll never see anything man-made in this whole region. It's very doubtful. And then this, I believe, is the bow of a ship. So it's definitely man-made. And I think that this could be where the gun was from whaling boat, potentially. But it's definitely a hard piece of man-made material. And it is right next to a whaling station. And then we found this very close by. There are no large trees on South Georgia Island, and I believe it's the mast of a ship. So we think we found a shipwreck there as well, off a Stromness whaling station, a former whaling station. Might be some buried treasure really close by, but we'll have to go back and check it out. I'm not telling anybody where it is. So we had a bunch of fish as well, swarms of fish followed us, followed the lights as well. They kind of loved us, and would come in and check us out. And then we had in about 300 meters, we have another fish, the notothenids. They're trying to take out some of the smaller fish there. And then this is really cool. This is one of the first times ever captured on film. This is one of the Death Stars capturing a fish. And we went back through and tried to find, was this the first time this ever happened? And it was not. It was in 1972 by Jacques Cousteau off of Deception Island. He filmed it in a submersible. So that was the first time that Death Star killing fish had ever been found. But then we're going to show you another clip where it's killing multiple fish. So it's grabbing multiple fish. And we think this might be one of the first times that's ever been seen. But just really cool because you see these sitting there and not moving around very fast, but you see how quickly it can move when it has a predator or when it has prey. So really cool. We haven't released that publicly, but we're going to go public with that pretty soon as well. So really awesome. A lot to learn about the Death Star down there. We're trying to blow up the Death Star if you're a Star Wars fan, to help raise awareness about Antarctica. So that's it. And then from this, you get a bunch of cool still shots as well. This is the crinoid. We can go to the next couple. If you can, so this is the reef. Again, really nice, beautiful shots. This is the Death Star killing the fish. And then you can zoom in on some of these and then really see them much clearer. So take some really, really kind of cool stuff down there. And those are our 8-meter waves we had to battle at sea. So let's open it up for questions about the tech, about the expedition, anything else you guys want to cover. But thank you guys so much for tuning in. And again, looking for opportunities if you guys are interested in trying to get researchers, especially grad students or undergrads on the ship and have an idea to hunt for the colossal squid. I'm all ears as well.
Awesome. Thank you so much, Brent and Matt. These were really incredible photos and video. I think everyone is probably feeling like me and pretty awed by what you were able to capture. So we do have some questions rolling in. Everyone, please join in in the Q&A. We'll try to get to as many as we can. I'll start with Deb. She asked, did you make any accommodation to the gear to be able to deal with the crushing icebergs, or was the method to pull gear out to mitigate troubling ice movement? I have worked in Alaska areas, in areas with immense sea ice, and a huge challenge with acoustic gear was the moving sea ice.
I guess I could start on that one there, Matt. Basically, we never really deployed especially if there's a lot of pack ice around. And because it's essentially a cruise ship, they would also generally not deploy Zodiacs in any kind of adverse weather or if there was dangerous ice around. So it did preclude us from deploying in certain circumstances where we otherwise might have wanted to. We did have to worry about smaller chunks coming and hitting, and Matt was there with a pole, pushing away some of those, and we had some Zodiacs pushing away some of the smaller bergs sometimes. But for the most part, we tried to avoid them as much as possible. And if we did have an inkling that anything was getting close, then we'd start pulling up the gear to get it out of the way.
Yeah, that Kevlar line was great. Prevented, we'd have smaller ones bounce off every once in a while, but yeah, the large ones, the ship tried to avoid pretty well, but it was a big threat. And there were a few, let's say, I don't want to tell Brent this, but a few kind of, pseudo close calls there of like kind of concerning how close the ice was to us. But they would use the thrusters as well from the ship, as well as, yeah, like they said, the Zodiacs, we'd call them in, and the guides, the expedition team, they had a thrill just plowing these icebergs out of the way with a Zodiac. So we had a lot of help is the bottom line on this, but we had to deploy through ice, around ice quite a bit. And that was always that we had to keep our head on a swivel to be monitoring that constantly.
Awesome. It does sound fun. Lee asks, really interesting, thank you. How much of this footage were you able to share in real time with the passengers, and how engaged were they in the survey?
Yeah, all of it. We shared with everybody on the ship. We do a recap, and so the whole goal was show them at the end of each trip on the way back over the Drake Passage. Before the end, we do our session as you just saw, and then do a Q&A and much longer clips. Obviously, we'd show them the full footage that we got underwater during their cruise. And every day, this is the cool thing, is that like we were right next to where the guests leave on the Zodiacs. So they get to come over our screen and look at what we're looking at, ask us questions in real time, which can be wild because you're trying to operate the thing and then talk to people. But yeah, every day they were like, Matt, and the whole team, did you find the squid yet? And people really excited on the project and just really excited about what we found in general. So yeah, the stoke level, if you will, the excitement level was extremely high. About the whole project, and we were thrilled to have the guests so engaged on this. So looking to do more of it on the outreach side. We've spoken to some students over the internet as well, and hopefully in the future we can maybe try to do some live Q&A with students and stuff like that as well.
Great, that sounds really fun. Julia asks, and we had a couple of different questions about this. Did you use any bioluminescence to try and lure in the squid?
Yeah, we did. This is out of Safety Net. They have a thing called the Pisces. It's actually trying to attract bycatch. So they have a really fancy flashy light that can go to depths, and they have different ways that they can control the flashiness on it. So it's a great product, used specifically for fisheries, but we were using it to try and attract the squid. As you know, squid are attracted to green lights and sometimes just even white lights. But sometimes they kind of stay in the periphery of the lights and try to stay just out of screen and try to get to things that they're attracted to lights. But we definitely used it. Not a lot of success on attracting things with the green flashy light on this one. And there's not a lot of predators down there in general in the midwater that you're going to see other than big squids and such. So there weren't a ton of large fish in Antarctica that we were looking for and otherwise. But yeah, we definitely tried to replicate bioluminescence with that. with that. And we talked to Edie Witter and the team from the Giant Squid expeditions as well about their e-jelly tech and whatnot. It's unclear if the colossal squid is going to be, nothing in its habitat is really looking like that flashy though. So it's not, it's unclear if it's using its huge eyes for offense or defense and whether it would be attracted to bioluminescence. So it may be that they're scared of bioluminescence because the sperm whales, when they come down, they create such, a plume of it that they may be trying to get out of the way. So we might be replicating a sperm whale by doing this. Well, so yeah, unclear, but we did try it on a bunch of dives. Yeah.
Awesome. That's super interesting. We've got 2 more Q&As in the Q&A box, so hopefully we can get to them. How important was crowdsourcing in your projects, and any tips for others who may be thinking about using crowdsourcing?
Yeah, great question. So yeah, thanks to the Experiment Foundation, any of you can go on and you can potentially get matching funding for your crowdfunding on there. So they matched us up to $5,000. Bottom line, if you haven't tried crowdfunding, it's a great way to go. Just try to get a lot of people engaged in the project in the first 24 hours. We had $5,000 donated in the first 24 hours. And it's because we lined it up and we had people engaged in the project for 7 years. We were leading up to this point, and we finally had a ship ready to go. So we were engaged on it. But really on the crowdsourcing thing, it's going to be the majority of your network and the people that you know. It's not going to be strangers. Don't expect just thousands of other people to just come in your project randomly. You're going to have to do some asks and have specific, text people the link, that kind of thing. So we learned a lot from the crowdfunding thing. That was my first time doing it. We also might try to crowdsource more ideas to find the colossal squid. But I'm all about that process. I ran, public prizes and competitions, and I love trying to get the public more engaged in this, in the hunt for the colossal squid. So yeah, strongly recommend trying to pursue it. Experiment Foundation, good platform for it. They have an ocean matching fund. I'm not sure if they're out of funding yet on that, but great way to go if you're looking to launch a project.
Great. And we've got from Cole, I was wondering the average height from the seafloor you tried to manage for these videos, and if you're willing to share some insights on how you determined the best lighting and camera systems. Cole has recently used a very similar system to study Greenland sharks in the Canadian Arctic.
Awesome. Yeah, we have a couple people on the line who also saw some Greenland sharks from Marine Institute. So maybe you guys know each other. So yeah, we tried to, we had an altimeter, as maybe Brent mentioned, so we could see the seafloor before we get there. The lights were also on, and we were pointed down. The direction of the camera was at the seafloor. So we made sure we could see it before we'd see it. In some cases, we'd go a lot slower, obviously, before we approached it. But there was so much biodiversity on the seafloor, we definitely wanted to get, within a few meters if we could. But you had to be really cautious, and you had to kind of, the topography down there wasn't too bad for walls and otherwise that you could run into, and we were drifting very slowly, so less than 1 knot at most usually. So all of that combined to let us allow us to do it and stay kind of closer. Brent, do you want to mention anything about the other tech components to keep it?
As far as like camera settings and whatnot, just having the real-time video allowed us to increase or decrease our lighting depending on how much turbidity was in the water. Choose our red over white LED. Let us tweak our different camera settings. Because again, it's all in real time. So
I want to say one more thing about the depths. The ship doesn't have an altimeter that was going to 1,000-meter depth because it doesn't need it. And so anything beyond 200, 300 meters, we were actually figuring out where the seafloor was. So we used literally the maps, the old maps, to try and figure out, and they were telling us, well, we think it's going to be this deep. And so we'd have to go out down there and actually discover it for ourselves at times if it was below 200 meters or so. And
because it's a cruise ship, we don't exactly have great topography maps. There's no side scan sonar available to map the seafloor before we do deployments. So there was definitely a very cautious approach to going down above the seafloor, as the ship drift, get a feel for the topography, and if there was any snag risks before descending down close.
Wonderful. super interesting to kind of use a different set of maps and all of that. Well, we are at time, so I wanted to thank you both very much again for sharing this incredible journey and the amazing technology you used. Please be sure all of the participants and attendees check out the Scripps Technical Forum online. If you have questions that didn't get answered, burning questions, let us know and we can pass them on to Matt and Brent and others at SubC Imaging. So thank you everyone again, and we will see you soon at another technical forum.
Thank you guys so much for having us.
Thank you very much.
Bye-bye.
Bye.